Hello class, this is Jacob, aka the Number Ninja. You can also call me Sensei if you want to get into it. And welcome to my dojo. Today we are actually recording the first video in my Pre-Algebra series. My goal here is to help guide you guys from the very beginning of Pre-Algebra to the end of the course. Cover everything that you should need to get a good understanding. Pre-Algebra is obviously a very important class, as everything else you do in high school and beyond builds off of Pre-Algebra, right? It's kind of the fundamental building block of advanced mathematics. So whether you're nerdy enough to want to do advanced mathematics or not, you're kind of going to need to know this just to graduate. My goal is going to be, of course, to make it easier to digest than you might have it in school. Obviously, there's some benefits I have that teachers won't, such as being able to do whatever I want and record it from the comfort of my own home and not have to also babysit you guys. So it's a little bit easier for me here to hopefully just give you nothing but the numbers, help you guys out, and hopefully by the end of it, you guys will all be black belts. That's kind of the little theme that we're going with here. Just a little bit about me, that way you know I'm qualified. Like I said, my name's Jacob. I've done tutoring for around, 7, 8 years now. I started off doing private tutoring on my own, just for some family, friends, and relatives, that kind of thing. Then I eventually joined a math tutoring company as an instructor, teaching things all the way from kindergarten through 12th grade, including some stuff like AP Calculus. So I have a pretty good understanding. I eventually became a lead instructor, and then I quit to take on an internship. And then after a year off where I did not do any tutoring whatsoever, a whole year, 365 days, I went back to private tutoring and have kind of been doing that ever since. So I know what I'm talking about. Hopefully I can deliver this information to you guys in a way that's easier to understand and hopefully a little bit more entertaining than class. The goal is to have these be around 10 minutes. That way it doesn't take forever to get through, but hopefully I'll also be able to cover the content you guys need. So, hey, it's Jacob here. I finished recording the lesson and I did not get even close to the 10 minutes that I just said. I don't know what I was thinking. It's a lot of material to cover, and 10 minutes is not going to do. So instead, what I'm going to do is separate this out into 3 separate videos for you guys. And moving forward, I will probably be uploading 2 to 3 smaller videos throughout the week rather than one big one weekly. This hopefully it'll make it easier for you guys to kind of digest the information as well. So sorry about that. I don't know why I thought I could talk that fast. But yeah, let's jump right into the lesson on real numbers. Good luck, everybody. All right, everybody, let's get started with our first lesson. So, we're talking about real numbers. There are also imaginary numbers. This is an actual topic, but it doesn't come up until Algebra 2, so we're not going to talk about those very much. Let's just focus on the real numbers for now. What's fake can't hurt you anyways, right? So there are 2 different kinds of real numbers. We have our rational numbers, and we have our irrational numbers. Rational numbers are the things that we like to work with more. They're things that you interact with in your daily lives. So things like whole numbers like 12, or maybe a fraction like 3/5 or something like that, right? These are numbers that do not repeat forever, and they can be expressed as a fraction or a whole number, something like this, even a decimal like 3.65, or even for decimals that actually do repeat forever but have a recognizable pattern to them. So something like 7.272727. Because we're getting this repeating 27, this would be rational. They terminate, or they don't terminate, I should say. They usually will terminate, but they either terminate or end in a repeating pattern. An irrational number does not do that. It will, a lot of the time, be a square root. So something like the square root of 3 or 5 or what have you. Or maybe a number you might know, pi, which happens to come up a lot when we're talking about circles. If it's not something you're familiar with, that's fine. I'm sure you'll learn about it soon, or in a few years, really. But these are irrational because if you do try to represent them as a decimal, pi, for example, it is 3.14159
2
and 6. and then it keeps going forever, but without a repeating pattern. It's just a seemingly random list of numbers that goes on forever. And I mean, you can look it up if you want. There are like thousands and thousands and thousands of digits, and they're still discovering more of them, like the better our technology gets, right? That's an irrational number. The square root of 3 also is, just because, 3 you can't get by multiplying two whole numbers, or one whole number by itself. So if you do actually do this, you get, I don't know exactly what it is, but it's going to be 1 point something. Let's just say for the sake of argument, like 1.2, 1, 5, 6, 3, blah, blah, blah. And it will also keep going. This is not the correct number. Don't look this up. But it will just keep going forever. So that's real versus or irrational versus rational. However, there are also a bunch of different subcategories of rational that we also need to talk about. So as we're going through this, just think about it as going from vague to more specific. Everything I talk about after rational will still be a rational number. It'll just be a subcategory. So rational numbers includes everything that is not irrational, right? So everything that terminates or repeats a pattern. This will be things like, again, 3, 0, -1, 4/5. Sorry, I'm gonna get better at connecting my 4s here. Or decimals like 2.16 because it terminates, etc. The first subcategory of rational numbers. So all of these are rational, but not all rational numbers are integers, right? An integer is a rational number that does not have a fractional component. So that means 4/5 would not be an integer. 2.16 would not be an integer because they have decimal and fractional values. Integers would be things like -4, -2, 0, 3, 7, 25. You get the idea, right? So numbers that don't have a fractional piece. Then the next subcategory, so all of these are integers, but not necessarily and rational, but it doesn't necessarily work the other way around, would be our whole numbers. So whole numbers are basically the same as integers, but it does not include negative numbers. So the smallest one would be 0, and then you get 1, 2, 3, etc. Again, 25, 100, what have you, right? Basically the same as integers, but no negative numbers. Okay, none of those. Then, I gotta go back to black here. The last subcategory are natural numbers. So natural numbers are almost exactly the same as whole numbers, but it does not include 0. So I know it's kind of silly that there's a distinction there. It matters for certain things, but not really for what we're going to be talking about. So that is the difference, is a natural number. All whole numbers are natural numbers except for 0, right? That's the one difference here. So natural numbers are all whole numbers, which are all integers, which are all rational. Hopefully that made sense. Feel free to review this again if you need to, but we're now going to jump into our next topic, which is doing integer operations, which, if you noticed, that's these types of numbers here. All right, and I think that's a great tease for what's coming out next. I'm sure you guys are very excited to talk about integer operations, but yeah, that'll be coming out probably in a few days. Again, I didn't want these to be too long. So that's it for the first lesson. Again, I hope you guys got some value out of it. Hopefully you learned a thing or two and it wasn't, as complicated as before. If you guys continue to train with me in my dojo here, I'm planning on doing some sort of belt system. So eventually we're gonna get to a black belt, right? But there'll be checkpoints along the way to go from your white belt to your yellow belt to your orange belt, etc. So that's something to look forward to. I'm not gonna give you guys actual belts, but I'll give you fake belts that you guys can pretend you have, but more importantly, you'll have knowledge, right? So that's the reason we're doing this. Hope you liked the first one. Keep an eye out for the next one. We're going to be talking about integer operations. So good luck with your exams and any homework you might have. Have a good one.